Welcome to one of the last videos in this unit, and now what we're trying to do is put all the different terms that we've learned early in the unit together with some of the graphing ideas from later in the unit. Just want to run through a couple of examples from this worksheet with you, and then towards the end ask you to do a couple on your own. Let's just start with question 1 here. If our function is 3 times x minus 5 being squared plus 7 at the end, you notice right now that it's related to a parabola. Okay, it's basically x squared, but we have all these different numbers in place. And if we think about what this form should look like, it's already in a nice form for us to describe the movements. And so in the instructions here, they ask us to sketch a graph. It's actually the last thing there, but it's probably the first thing I would do. And then think about what the domain would be, the range, and also the end behavior. Now, we can do a lot more than just that, but that's going to be the minimum of what we look for. Oops, did not mean to do that. There we go. Okay, so I'm just trying to scroll over there. There we go. So first, let's go ahead and just do a very informal sketch of what we would see here. Okay, in this form, it looks like with the x minus 5, we're moving to the right 5, and the plus 7 at the end, we're going up 7. So I know that the vertex of this graph might be somewhere right there, and I can even label it 5, 7. Okay, now the 3 is going to do a vertical stretch by 3, and that's really hard for us to visualize here. So as long as for this particular equation you have this parabola opening up, I'm not going to be too picky about it. Now we can certainly do more with that. We could certainly talk about plug in a few points and kind of make sure things end up looking right. But in the end, that's really the best thing for us to put down here. Is just it's a parabola that opens up. Some of the other functions that we look at maybe we'll be a little bit more picky about. Now the instructions say at this point, based on this, list the things like domain and range. A parabola is a little bit easier to work with, so our domain, if I use, well, I could just say it's all reals, right? So if we want to use that sort of notation, all reals for that. The range, though, is a little bit limited. Okay, range is the y value, so it goes from 7 to infinity. This last part of the instructions is probably the trickiest here. How do we describe end behavior using limit notation? So do realize on either side, on the end over here it goes up, and on the end over here it goes up. So limit notation basically says write limit. That's something you always do. Right below that you say, well, what am I trying to describe the different x area? And since it's doing the same thing, since the y values are doing the same thing on the right and the left side, to keep it kind of simple, I could say as x is approaching positive or negative infinity. So now when I write it this way, I'm saying what's going on either side, on the right side or on the left side. And then I want to say I'm trying to describe what y or what f of x is doing. Okay, so this is describing where I'm looking. I'm looking on both the right and the left side. Now I'm starting to describe what y is doing there, or what f of x is doing there. And on both sides, it's approaching infinity. If it was doing something different on either side, then I'd have to write two separate ideas like this, one where x approaches infinity and one where x approaches negative infinity. Now we can do a lot more with this kind of a question. I'm limiting what we're asking right here, but at this point I could say, well, how is this function bounded, or where is it increasing or decreasing? What's a max or a min? What's the symmetry? Is there symmetry? All those other terms that we used early in this unit we could also be talking about here. Okay, let's look at one more, maybe one that's a little bit more complicated. So let me erase that, and we're going to scroll down. Okay, let's look at question 4 for a little bit. Now this is related to a square root function, and so we are, again, going to try and graph this as best we can. We need to notice that it's not in the 100% correct form for us right now. X is not by itself. So one of the first things I might do is just take a minute to rewrite it. So I could rewrite this as, if I factor a 9 out, I'd have an x minus 4 left behind, and then still have a plus 5 at the end. Okay, now this tells me a few things. There is certainly a vertical stretch that's going on by a factor of 3. There's a horizontal compression by 1/9. Again, those are going to be kind of hard to draw for this particular shape. So I'm not going to be super picky about that. In class, we could talk a little bit about how we know more exact coordinates for some of this, but the big thing for me is that I went right 4 and I went up 5. So as I sketch square root, go right 4, go up 5. Hey, our friend's back. There we go, get rid of that. Okay, so we went to the right 4, we went up 5, so this coordinate right here, maybe I write in, is 4, 5. Okay. And now we start thinking about some of the questions that are being asked here. So they're asking us, what's the domain? What's our x values? Okay, well, I'm starting at 4, and I'm going all the way to infinity. So 4 to infinity, and 4 is included because that is the definite endpoint. Okay, the range, that's the y value, so that's 5 to infinity. And then again, we talk a little bit about limit notation. Now, here it's not doing the same thing on either side, so I need to first of all talk about what's going on as we approach infinity on the right side. So this is how I say, think about the right side. Now, what is y, or what is f of x, doing on the right side? And it's going to keep climbing. And then I'll give you some options for the last piece here. But we certainly want to say, well, what's going on the left side? So at negative infinity, there's a negative symbol right there. That didn't come out so clearly. What are the y values doing? And for this one, there are no y values on the left side, right? It's blank over here. So we can just say D, N, E for does not exist. But again, from here, we could answer or ask a whole lot of other questions. Where is this function increasing or decreasing? How is it bounded? What's a min or a max? Again, all the other terminology we should be able to answer based on this informal sketch that we have here. Now, certainly some of the other equations that you're going to see on the worksheet are a little bit more complicated. And it's going to take a little practice to remember what they originally look like and how some of these values would change them. There are certain graphs where thinking through the a and b values will also be important for how we come up with some other ideas. But I think overall that's going to be the most important thing, is that we understand to get an informal sketch, and then we're used to answering some of these kind of questions. So probably a couple questions here at the end of the video for you to answer. Take care of that and come with some good questions into class.